Hello, my name is Andreas Fleischmann. Welcome to this Cabin Configurator tutorial for DigiPara Liftdesigner for Autodesk Inventor. Before we start, I want to give you a basic impression what we want to do. So this tutorial will show you how you can automate a cabin wall panel with DigiPara Liftdesigner in Inventor. And we have 4 basic steps. One is that we have to prepare your Inventor part. The second step is that we add this part to the DigiPara Liftdesigner Database, and in the third step we will specify a complete cabin configuration, and finally we will automate the DXF creation for manufacturing. In this first minute I want to give you some basic terms. So Liftdesigner is based on the DigiPara Liftdesigner Database, which is a Microsoft SQL database which is on your computer, and it stores your elevator, what we call Masterparts. And the DigiPara Liftdesigner Database does not store any project-specific files. And we will use DigiPara Liftdesigner Datamanager to edit this database. DigiPara Liftdesigner distinguishes between 2 types of files. One type of file are Masterparts. Masterparts are typically engineered by your R&D development department within Autodesk Inventor. And Masterparts are stored in the DigiPara Liftdesigner database. On the other hand, we have Projectparts. Projectparts are created by DigiPara Liftdesigner during a concrete elevator configuration. So when you have a specific project, DigiPara Liftdesigner will create project parts. And project parts are customized copies of your master parts. The master parts are stored in the DigiPara Liftdesigner database, and these master parts are usually parametric parts with variable dimensions. Master parts can consist of IPT files, IAM files, and also drawings like DWG and IDV, and some other files. The project parts are used for one specific project only, and each project part has a correct project-specific dimensions. You might have different sized project parts based on the same master part. Changing a project part will not influence any master part in the DigiPara Liftdesigner base. It's very important to understand that everything what you do in a project does not influence the database, and opposite. And finally, we are talking about the project folder, which is an individual folder on your computer, and every order or every project, every elevator project that you create will have its own folder. We recommend to have this folder on your computer. Do not put it on a server, because then you have strong performance limitations. It's recommended at the end when a project is completed that you check that into Vault, or that you copy this on a network drive for backup purposes. DigiPara Liftdesigner organizes and maintains the project folder, and that means that we also clean up this folder if some file is remaining from an earlier modification. And it's important to understand master parts become project parts. By copying from the Liftdesigner database into the project folder, the master part becomes a project part. So every part that you want to add to the DigiPara Liftdesigner database, you need to check up before whether it works as it should. So in this example I have 2 files here, which is one is my cabin wall panel IPT, which is a simple part, and the related DWG file. So let's have a look at the IPT file. It's a very basic file, and then we have a related DWG file just for demonstration purposes. So it's a good idea that the main parameters that this part has have a good naming. So if we check here under Manage and then Parameters, you see that the model parameters are D0, D1, D2, and so on. But I want to rename these 2 parameters here. So let me call this my width. I give it a specific naming so that we can easily identify that later. So my height. So one is the width of this component and one is the height of this component. And now we should try out whether this model works as it should when the parameters change. So if I go to the width and change it from 293, let's say, to 500, done, then we see, okay, it works probably as it should, but you see the holes here, there is probably a third hole is missing, or the holes are not properly aligned. Also these holes are not properly aligned. So let me go ahead and change that. So what I will do now is I will change the sketch. Okay, and we want to have this aligned in the center. So what I will do is I will change this dimension from 141 to 0.5 multiply, and then I choose the parameter, list parameters, and the parameters is my width, and then it's approximately in the center. This should be sufficient for this example, but I want to show you something else. That is the base point. So there is no clear base point here, and if I change parameter manage, and let's change the height to 2000. Then you see what happens in this sketch here. That here is the base point of the model, and there is no relation between that. So what we should do is we should have a coincident constraint here so that this fits properly. And now if we try everything, manage parameters, let me resize that, make that smaller. We make it higher, 2400. You see there is a distance here between these two items. We should adapt this also. Let's put it 600 here. So it seems to work quite properly. Not every component is properly aligned. So this is not. So you see what you need to do. You need to justify all the things so that your component properly changes as you like for the different sizes. Before we can add the product to the database, we have to prepare the database. Let me give you a basic explanation how you edit the database. So the tool is DigiPara Liftdesigner Datamanager, and what do we see here? We have some ribbon interface, and on the right side we have different windows, and under table view you can choose which component you want to modify. So we have for every component we have different items here. So let's have a look at car frames. You see here are the different car frames, in this case from the company called CMAC. So with this combo box here, you choose the corresponding area inside the database. It's logical, split it into different manufacturers. So let's have a look at one of these other. Let's have a look at ThyssenKrupp, and then you see here are the different castlings from ThyssenKrupp. So if I choose one of these items, I see here on the right side in the table data editor the values. You might modify here the record on the left side, or you might edit on the right side here in this green window. So the green window becomes more important if you got more columns. So if we view here, we have a very large. Let me resize that here. So if I resize that, then you see there is a large list of items that you can edit for this particular car frame item. So what I would recommend you, if you have a dual screen, put this table data editor full screen on the second screen. So this is what we recommend how to work. In this example, I just put it here on the right side. So, but we have to do one preparation because we want to make a new module. I want to really start from scratch, and creating a new module goes under manufacturers, and we add one new manufacturer, and I call this my cabin manufacturer. And we have to put some specific number here. And what you need to know is that this number is, I will choose 4312, but never use that number. 4312. You get numbers from us, so you get unique numbers. This makes it possible that you later can change, exchange your product data with other companies. So don't use any number that I use here. So talk to us and we will give you a set of numbers that you can use. And the number is always preceded by 5 zeros, because it's 4312 and then 5 zeros. This is the specific range where we can add our product data. Developing a component for Autodesk Inventor and Liftdesigner is always done within Autodesk Inventor. So where do we need to start? Usually we start in Liftdesigner in Inventor and we create a new project. And in this example we now concentrate on the cabin. So it's not really important what type of elevator we choose and where is the counterweight. So I simply choose next here some basic elevator. I choose 2 floors and 2 floors, and then I'm done. Now I have to give a name here. And I did a specific folder called orders, and in this order I put I call this develop my wall panel. And now the software asks me whether I want to perform a full update. I choose no. I will now give you a basic explanation how the update process works. So Liftdesigner always sets up the complete configuration for a complete elevator. This is the way it works for all cases. And I go to elevator properties, and what I see here on the left side, I have a shaft element, which is the top level node for one elevator, and there is almost nothing below that. There are almost no siblings below. This is because we have not updated everything. But under shaft we have the car and some other items. Here on the right bottom you see that the top level is the project file, and this is shaft 0. And let me show you, for every component that you have in the elevator model, you have CAD settings, and there is one basic setting is called create geometry, and this is always set to by parent. But if it's a shaft object, by parent means create. But what I want to do is I say do not create, and then the number of derived shafts, which is the concrete for this elevator model, I always put, in this case, put to 0. If I update now everything, you see everything disappeared on the left side because I have not created any object. Because the car under the shaft is also using by, let me see here, now we have the car selected, and the CAD setting says create geometry by parent, and the parent is the shaft, and the shaft is disabled. So what I can do is I can choose here create, and then all siblings of this car gets also create due to the by parent setting. So let me update this and you see what happens. It creates a shaft object on the left side, but it does not create shaft geometry. It only creates the car and related components. And it's probably interesting for you to see that the car also contains the guide rails, because internally in the Liftdesigner configurator model, the guide rails are always a sub-object of the car frame, or also of the counterweight frame. Counterweight frame also has guide rails. The benefit is if you move the car frame, the guide rails move with it. So what we can do is, under the car there is a car frame object. You see here the blue one is the selected one, the red one is the parent one, and the green ones are the children of this object in the data tree. And I choose car frame, and then I choose here for the car frame, I choose do not create. And when I update now, the car frame and its children disappeared, and now I only have the car and the car door. Now I go to the car, and there is, every component has one object called LDGeo, which is the geometry object. And especially here for the car, we don't need that because we want to later we add the cabin configuration. So what I will do is I will disable that, and now I have an almost empty car, just a platform and a car door. So we are still in the preparation stages. So what we need to do is, since the standard elevator does not contain a cabin configuration, we have to customize the cabin configuration. So I go into the cabin configurator and enable a car design. And to make it easy for you to see, I choose a panorama cabin. So let me see how that looks. That's the way a panorama cabin looks like. And in the cabin configurator, you can determine what you want to add. So I will disable the ceiling to make it easier for you now to see how that model works. So we now have a car without ceiling, and even on the walls we can enable kick plates and disable objects. There is some minor problem here. It's COP 3 and 4. We need to disable this also. So we have to, and the car operating panel 1 is on the right wall, so we can choose another car operating panel. I choose the full cabin height panel. What I would recommend you is simply try to do what I am doing here. So I will give you some basic start points here to understand the software. I move this car operating panel approximately in the center, and yeah. So, and on the left wall we have handrails. So I will disable on the left wall the handrails and the kick plates, because we will use the left wall to develop our new component. So why do we see no cabin? It's because we haven't updated. So anytime when you make a change to the Lift Designer elevator configuration, you need to update the model, and you see what happens. It sets up the complete cabin. It's always a good idea to save the project. So at this stage, at latest, I would recommend you to save your project, your Inventor file. And you see here on the right bottom how many files are created. So we have around 145 files and 206 instances of the different files. So all these files are controlled by DigiPara Liftdesigner. You don't have to care about location and type. There is, if you want to select a single component, just as a reminder, here is a button, select by part priority, and then you can choose single items here. So I can choose this item, and then you go to find in browser, and then in the data tree you see this object, and what we have here is wall 1, 2, 3. Wall 3 is always the left wall. So in Lift Designer we have 4 indices, 1, 2, 3, 4. 1 is always front, 2 is always rear, 3 is left, and 4 is right. So this is the way it works in Lift Designer. And then inside at the left wall we have panel 0, panel 1, panel 2, and panel 3. And we can use any of the panel to develop our component. And what I will do now is I will every component has a LDGeo object here, what you see here. And when you develop a component, you need to develop this inside this LDGeo object, and you develop your components here inside. Before we can do that, we might not change. So you see, this is a glass panel from the manufacturer common cabin components. If we would now add your parts in this, we would update the library with regards to this common cabin component library module. This does not make sense. So before we can do this, we have to exchange the component against one of your library. I will show you how that works. So what we have to do next is we have to copy this component in the database and make a component that is not from the manufacturer or module Cabin Common Components. Instead, it should be from our new module. So it's important to understand that you might not change the Common Cabin Components object. So what I will do is I go in the Data Manager and I choose the corresponding object, which is the glass panel U-shaped. And then there is a function called create a copy. And the system tells me, okay, what it needs to copy. I choose next. And now I choose the system that the module that we have created, my cabin manufacturer. and I click on copy, and it says, okay, everything is copied, close. And now I switch to this module, which is 4312, and then you see we have a glass wall panel U-shaped with a number, with another number. So let me call this, even we don't want to have a glass panel, we have a steel panel. So I call this my steel panel, and I call this here tutorial. This might be the type. Okay, so I'm done. So what I can do now is I can go into Liftdesigner, I choose that, and I can choose a different one here. And I can choose now my cabin manufacturer, my steel panel tutorial. I choose that, and this will replace panel number 2 in this object. So if I update now everything, you see that the model is updated, but no surprise, it looks similar because we have exactly copied the same object. But you see that it's important to understand that it's a different object. So this is common cabin components, and this object is my steel panel. If we want to change all objects on this wall, we can go a different process, because also the wall, the overall wall configuration has a specific setting, and this is what I want to change now. I have the cabin wall, and I go to common cabin components. Common cabin components here. Do not be confused with common cabin components imp, which is imperial. Never use imperial. Always choose 1114. And we have a configuration here for front wall, rear wall, left wall, right wall. So I choose the steel cabin here, and I will copy all 4 walls. Then we are prepared also for the next step. I choose create, next, and now it suggests here the recent module, my cabin manufacturer copy, and then I say close and open copy, and this will automatically bring me to the same car wall table. And now I have steel cabin here. So what I will do is I call this my steel cabin, my steel cabin. And we have different columns here, but it's good to see here what we can do in here on the right side now. For every wall, we can exactly determine which type of bumper rail we want, which type of handrail, which type of mirror. And 0 means it's not used, but if we have such a number, a specific object. And you see here the wall panel is 1114, which is common cabin components steel. But we have to choose a different one now, because we go to my cabin manufacturer and we choose my steel panel. And it simply changes this number, 4312, and then all these zeros. This is exactly the number of this single steel panel item. And you see here, if I make this smaller, then you see here that the system has added it here. So you might edit in this green window, or you simply can edit here. And then we have the default width of the panel. Let me change that. That's a good idea. So if we change this to 444, just to remind that, then, and the seat, we don't want to have a kick plate, so I set the kick plate also to 0. And now the wall only has the wall panel. Let's have a look for the other items. So I disable the mirror. This is now for the rear wall. No handrail, no bumper rail. The wall panel is correct, and no kick plate. And the same for the others. No bumper rail, no handrail, no mirror, the wall panel, and no kick plate. And finally for the right wall, let's keep the mirror on the right wall, just that you see that how that works. So we disable the bumper rail and the kick plate. And I set, for every wall I set it to 444, which is the width of the wall panels. Okay, so I'm done. And what I can do now is I can exchange the complete left wall. So the top level object is now a wall. The wall configuration, I go to my cabin manufacturer and I choose the left wall here. And if I update this, then you see that the items are still made of glass, but you see we have more items. Why? This is because you see we have panel 0, 1, 2, 3, 4. This is because every panel has a width of 444 millimeters, and maybe before there were larger types. So the reason is that we now need 5 items here to make this happen. So even for wall number 2, we can do the same thing. We can choose my cabin manufacturer, rear wall, and do the update process. Okay, so this can be done for each wall, but we can also customize the overall design. So we can go back to the Lift Datamanager, and there is under table view there is cabin design, and I will go to common cabin components, and I choose the first, the steel design with U-shaped panels, and I choose create a copy, my cabin manufacturer. I copy this record and go to close and open copy, and let me resize that here. It says this is now my steel cabin design, and my steel cabin design is one second, save that. My steel cabin design consists of the different walls, and what we have to do is now we have to choose the correct wall. So this is the front wall, my cabin manufacturer. I choose front wall. This is my steel cabin front wall, and the same the cabin rear wall, my cabin rear wall, my steel cabin rear wall. Then for the left wall, and for the right wall. So what I did now here is I assigned the wall configurations that I did before to a complete cabin configuration. Cabin ceiling, I put the ceiling to 0. Ceiling means do not have any ceiling, and I keep the cabin floor the way it is. So then I'm done. And what I can do now is I can remember that here on the rear side we have common cabin components, and also on the front wall, even there is just a small one, we have common cabin components. So what I will do is I will go to the design and change the complete cabin design. So I go to my cabin manufacturer and choose this type. Update all. And this will make now build the cabin walls based on our prepared components, and we can now in the next step go ahead and replace these components by with our geometry. So we are now prepared to add our geometry. So I want to do this here for panel number 2. It's not important which of the items you use, but let's choose one in the middle. And it's important to understand that every component has an LDGeo object, and the geometry that is saved back to the database that we do later here with save to database is the LDGeo object with all the children. So what I need to do is we have the geometry key of this component is LDX Carvel panel 193, and there is a related geometry path. Don't forget to save before the Inventor project. Then you have this folder, and we see the geo object, which is this one, and the 2 profiles. And what we need to do is we need to copy the cabin wall panel, that we prepared at the beginning of the session into this folder. It's very important that these files are in the correct folder. Now we go ahead and we open the LDG object, and then we place the car wall panel from this folder into this model. We can delete the default geometry because we only want to have our geometry, and then we have to constrain the location of this object relative to our component. And the geo object has an origin and has a x, y, z planes, and it's very important that you constrain to these planes. So I would really recommend you to do that. So don't constrain to any walls or any other planes. Use this plane. So I make a constraint between this plane and a quite similar plane at our cabin wall panel. Then we constrain this plane here with, 1 second, we constrain the front wall and do a constraint to this, apply. And finally, we do a constraint from this to this plane. And since this is the wrong location, we have to move it up, let's say 2000 millimeters. Okay. Wrong direction, apply. I will later show you how you can justify the 2000 millimeters. We have to take care on that, but we have now 3 constraints. What we also have to do is we have to map. We have to map the width and the height so that it properly fits into our model. So I go to DigiPara Liftdesigner, I go to parameter mapping, and choose the My Cabin Wall Panel object. Okay, here is something. Save. So choose the My Cabin Wall Panel object, and there is standard mapping and manual mapping. So go to manual mapping, click on add mapping, and there is a first mapping group, and add a single action. It automatically suggests you the current object, and we choose the value, the dx value is the width of the panel in the Liftdesigner Configurator model, and we want to map it to this document, which is the My Cabin Wall Panel IPT, to the My Width parameter. And then we have another, we also need to map the height, but the height is a parameter of the wall. So I go one level up here to wall number 3. It says me.parent, this is the internal storage, and we choose the height here, and we map this to my height. So it takes some time to get used to all these parameters, but it's working fine. So that's all we need to do, and now it automatically works in our Liftdesigner system. So I save everything into Inventor, all Inventor files, and we can now go ahead and save this configuration to the database. So I click on Save to Database. The software comes up with this dialog box, and I click on, and you see here, this is the target folder. We will have a look, open folder, where this gets saved. So currently there is no content in this folder, but if I click on Save Now, and we have a look at this folder, then we see there is a configuration, and the files have been slightly renamed. So don't change anything here inside. What we see now here are the files inside the Liftdesigner database. So my pool 4 is the database folder, and now this cabin wall panel has been saved to the database. What we can do now is we can place this also. Let's say let's do it at the rear wall. So I go to wall number 2, and to make a change happen, we always need to change between two components. So we already have the my steel cabin selected, so I choose something different. I choose my rear wall. From you can choose any value here, so it's just to make clear to Liftdesigner that you have changed something. So I choose a common cabin components, and now I change back to my cabin manufacturer rear wall. And if I update now, you see what happens. It replaces all items at the rear wall with the new ones that we did before. You see we have now 3 items here showing the wrong length. You see there is a wrong length here. Why? This is because there is some update is required. So simply click second time on update, and then it should work. You can also see the update process. There is some protocol here, which is pretty large, but let's see how that works. So let's say we change the car width. What would happen is that we get a change to one of these rear panels. So let's do the car width of 1200. You remember we have a default width of 444, and currently this item is 312, this item is 444, and this item is also 444. Now we update everything. This will reflect that the third item becomes smaller. Update again. And then we see this item is 312, 444, and 444. So this has been properly updated. In the report, you see you will see the corresponding change. And this is what we can do with the. Now we can go ahead and change the whole cabin configuration. So I switch to one of these default configurations. And now I switch back to my new this will reload. I mean, changing back and forth to another configuration will simply reload our configuration. I click on OK, and now we update all things. And you see here in the report on the bottom, it shows what the software is doing. It loads from the database our component and brings it into our model. So let's run that. Yeah, and you see here on the bottom that several dimensions have been changed to the corresponding values. When you get this error message here, you need to do a global update again to tell Inventor to update the model exactly according to all these parameters. This takes a second or so. Okay, there is some warning. Make sure that you get no warnings. And now you see we have all these wall panels here properly in the model. Okay. So that's almost everything you need to do. We have now developed a model of the cabin wall. We have added it to the database. We have loaded the cabin configuration. Yeah, and finally we can do some manufacturing drawings. So we are almost done, but we have to adjust a few things. One thing is that you remember that we have made a flush assignment with 2000 millimeters, which is a fixed value. This is not a good idea because if the car size changes, so let's change the car size to make that visible. So I go to design, not design, I click on the car and change the height. Let's change it to 2600 just to make visible what happens. And I update the model. Then all items are updated. And after the parameter mapping has run, we see that the wall panels are not in the right place. This is clear because the wall panel is 2600 and the constraint says 2000. So what we need to do is, let's go on Find in Browser. We need to change this flush element here. And let's go into cabin wall panel. Okay, I need, for this geo object, I also need a mapping. So I add a mapping, a parameter mapping here. Add mapping. And oh, 1 second. First of all, we have to look. The 2000 millimeters. Go into this manage parameters, and there is a D2 is a 2000 millimeters, and let me call that the wall height, just to remember the name. The wall height is 2000, and now I can go and do a mapping, parameter mapping, and it's a parameter of the wall, and I map this to the wall height. So, and this will now update the wall height based on the height of the wall, and this will then place everything properly. Yeah. So if I click update, once again update. Okay, it just updated one item. This is clear because I changed the one item. There is another change required. I want to do that in the same step. I go into the cabin wall panel, and I want to create a rule for driving the part number of this product. So what we need to do is now is we do some iLogic rules. So we add a rule, and we call this part number rule. And yeah, I would recommend you to have a look at iLogic and what you can do here. But since you really need that, I want to show you the basic thing. So we use the model parameter. So what we want to do is we have an I property, the part number, and we want to assign the part number the width and the height. So we call this wall panel. So put this in wall panel, no, blank plus C string. This is the command to width, my width, plus C string, my height. This is a small iLogic rule, and okay. And then I have an event trigger, and I want to run this rule before save document. Second. Before save document, select rules. I have to choose the part number rule. Okay. So when I save now this document, the rule has run, and if I view iProperties, you see here on the project wall panel 444 minus 2600. So this is not an iLogic course here, so you're really recommended to have a look at iLogic. Now we have to save this panel here, so I go to the panel and save it to the database. This is saving the modified component back to the database. I click on save, and everything is saved and updated. Successful. And now we have to go the same process as before. We have to change back and forth. I choose a common cabin components, one of these items here. So it changes the whole cabin design, changes all walls, all wall panel items. And to make that happen in Liftdesigner, now we change back to my cabin manufacturer. Okay. And now I click on update, and what happens is that the system removes all these old wall panel items and loads the new updated items. And now click on update all again, second time. To make Inventor update everything. And now we're done. So, and now it's the amazing part is that when we choose this object and we choose iProperties, you see this object is a wall panel 312 2600, and this is a panel 444 to 2600, and so on. Even this is a specific one. This is a 324 to 2600. So if I change the car height to 2420, just to make a specific value, and I update everything, it's clear what happens, that all wall panel items are updated due to this mapping, and due to this iLogic rule. When we save everything, all iProperties are set properly. So I click now on save, and then all our iProperties are correct. So now let's have a look at the different results that we have. We have 4 walls, and for every wall and every wall panel we have a specific folder. So let's have a look at the folder. Remember, at the beginning we also had created a DWG file, and yeah, we have very many files here inside. So before we check the results, we should go on delete unused files. That cleans up everything. So as long as you have not created a real geometry, you can choose select all and delete. It only deletes the files that you don't need. So let's go back into this folder now, and you see now everything is cleaned up. We have the geo object, which is related to this component, and we have my cabin wall panel here, and there is the IPT, and there is also a DWG. So let's have a look at the DWG, and we see this is a 444 to 2600, and but let's have a look at the last one here, the smaller one, which is 312. So it also has a folder, a specific folder, and if we open this DWG, you see that is the type with 312 to 2600, and everything is fully constrained, fully updatable. So that means if we increase the car width by 50 millimeters, let's say car width 2, then the last item will become larger, and currently we have 312, so we should get 362. So update all. It will increase the width here on this last item. And see here, 1 second, we need some update here. So let me run this update again. It's always the same point. It needs some update. And now we have 362. So what you get here is, together with the automatic installation of all these panels, you get a drawing for every item. And if you need DXF files for manufacturing, we have a tool which is the DXF exporter. Currently you get this user interface. There will be a new version soon, but this DXF exporter, you say find all sheet metal parts in current assembly, and you see here what happens. It's always the same part, more or less, but based on the part number, the system determines the quantity. You have different options here what you about the result of the DXF, and then we can say export DXF files. I choose this unfold folder, and it creates now the DXF files for this for these files. So let's have a look. Let's have a look to the unfold folder. Here it is, and you see what happens. It creates a DXF file for every item. It tells you the quantity, so you can use these files now for manufacturing. Let's open one of it in AutoCAD. So so let's choose this here. This is the 444 type. So we have some DXF here with the 444 type. You can show it with bend lines or without bend lines. There are very many options, the typical options that you, but this is the type with the 444. And then we have the other type. Let's choose a small one, a 50 millimeters panel. And you see here, that's the way the small one looks. So you are now at the end of this tutorial. Thank you for your time. I mean, we have spent 45 minutes to create our own part, add it to the database, and based on this configuration, we now have our own cabin design, which you can use at a very good start. If you have any questions, any hints, any ideas, let us know. You can contact the sales team at sales@digipara.com. And yeah, any feedback, even on this tutorial, is much appreciated. Have a great day, and bye-bye.